Think about dolphins and ancient ichthyosaurs. One is a mammal, the other was a reptile, yet both evolved streamlined, torpedo-shaped bodies. For crustaceans living on the chaotic seafloor, the winning design is often a wide, flattened shell, a tucked-under abdomen, and sturdy legs. This body plan is incredibly practical. A low center of gravity keeps you from getting flipped by waves. A flat shape lets you slip into crevices for shelter. An armored shell turns your whole body into a walking shield. It's a robust, versatile blueprint that just works. The fossil record shows this isn't a new trend. True crabs appeared over 200 million years ago. But long before and after, other crustacean groups were trying on the crab-like form. Some of these early experiments didn't make it, but the pattern of evolution returning to this shape is undeniable. Why? For many crustaceans, it's a relatively easy change to make. They already have a segmented body and a hard exoskeleton. Shortening the abdomen and widening the main body shell often just takes a few tweaks in their development. It's like an evolutionary path of least resistance. In contrast, think about a lobster. Its long, muscular tail is so central to its body plan that turning it into a crab would require a massive, costly overhaul. For many others, the crab route is the low-effort higher-ward option. And once a lineage goes crab, it rarely goes back. Some of the most fascinating examples are king crabs. You'd think they're just big, spiky crabs, right? But genetically, they aren't true crabs. Their ancestors were likely hermit crabs, the kind that live inside snail shells. At some point, a group of them ditched the borrowed shells, hardened their own bodies, and evolved a wide, flattened shape effectively, reinventing the crab from a completely different starting point. This shows just how powerful the pressure to become crab-like can be. Then you have porcelain crabs and squat lobsters. They look like crabs, act like crabs, but they belong to entirely different branches of the crustacean family tree. Each one is another instance of nature arriving at the same architectural solution to the same set of problems. So why is this shape so persistently successful? It's all about physics and survival. A flat profile reduces drag from water currents and makes it hard for predators to flip you over. Different evolutionary path, same functional outcome. Scientists are still digging into the details of carcinization. Is the crab shape an evolutionary peak that many lineages are drawn toward? Or does it only appear under very specific conditions? The answer is likely a bit of both. It's partly about the ease of the developmental pathway and partly about the strong ecological advantages. What's even more amazing is that new genetic tools are revealing that different crab-like animals achieved their similar shapes through very different genetic changes. The destination might look the same, but the evolutionary journey to get there can be unique for each one. So, will humans ever turn into crabs? The answer is an emphatic no. Our anatomy, our development, and our entire evolutionary history are on a completely different track. The phenomenon of carcinization isn't just a funny internet meme. It's a powerful reminder of how evolution works. It's not always about boundless creativity, but often about finding practical, repeatable solutions using the materials at hand. And when nature keeps returning to the same answer, it's a sign that it's found something that truly works. Thanks for watching, and if you enjoyed this deep dive into evolution, don't forget to like and subscribe for more.